In just 7 years, 24 rabbits had become more than 14,000 here.
What happens when thousands of rats are dropped on a remote island? Or when scientists decide to blow up a whale carcass with dynamite?
It couldn't be cut up and then buried because nobody wanted to cut it up, so dynamite it was, some 20 cases or a half ton of it.
From parachuting cats in Borneo to the explosive whale experiment in Oregon. These ecological trials often ended in chaos and surprise. Stay with us as we count down the 20 most bizarre ecological experiments ever conducted. Macquarie Island Miracle. What happens when thousands of rats are released on a remote island, causing consequences that shock everyone? This was the case on Macquarie Island, located in the Southern Ocean, which about 10 years ago faced a severe crisis. The island's native plants and animals were under threat from an infestation of rats, mice, and rabbits that disrupted the delicate balance of life. At that time, scientists embarked on an ambitious and complex mission to restore Macquarie Island's environment. The goal was to eliminate every invasive rodent and rabbit across 12,000 hectares under extreme weather conditions. This large-scale eradication effort was one of the most challenging in history, demanding careful planning and coordination. A decade later, the results have exceeded expectations. Native vegetation is flourishing once again, seabird populations have increased dramatically, and the island's ecosystem shows clear signs of recovery. Macquarie Island stands as a powerful example of how dedicated human intervention, combined with nature's resilience, can reverse environmental damage. This success raises the question, could similar restoration projects be achieved on other islands suffering from invasive species? The Macquarie Island case offers valuable lessons and hope for future ecological recoveries worldwide. The Great Rabbit Catastrophe. How a small decision can totally snowball into an ecological nightmare. Back in 1859, Australia introduced just a handful of European rabbits. Seemed harmless enough. They were brought in for sport hunting, nothing more. But this innocent move quickly turned into one of the most bizarre ecological disasters the country has ever seen. Those rabbits, they multiplied like crazy, fast. With no natural predators and a landscape perfect for breeding, their population exploded into the hundreds of millions within decades. The bunnies went from a fun hunting target to a full-blown invasion force, transforming lush areas into barren wastelands. Farms were ruined, native plants got wiped out, and entire ecosystems went off balance. Australia tried all kinds of wild control methods to stop the madness. Fences stretching for miles, poison bait drops, and even introducing diseases like the infamous myxomatosis virus. Some of these efforts worked for a bit, but the rabbits kept coming back, stubborn as ever. It was a never-ending game of whack-a-mole. The Great Rabbit Catastrophe is a classic example of how human interference with nature can spiral out of control fast. This story isn't just about rabbits. It's about understanding the delicate balance of ecosystems and the unintended consequences of tampering with them. So here's a query for you. How many other small actions in history might be hiding massive ecological shocks behind them? The rabbit saga definitely shows that when it comes to nature, even the tiniest ripple can turn into a tidal wave. Bet you didn't think a cute little rabbit could cause so much chaos. Explosive whale experiment. With a dead whale stranded on the Oregon coast in 1970, officials faced an urgent problem: how to dispose of the massive carcass quickly and effectively. Their chosen solution was unconventional, using dynamite to blow the whale apart. The explosion certainly achieved its goal of breaking up the whale, but the outcome was far from what anyone anticipated. Large pieces of the whale were hurled great distances, damaging nearby cars and showering onlookers with debris. Rather than a simple cleanup, it turned into a chaotic and messy event. The plan had been for scavengers to consume the scattered remains, but the blast created more problems than it solved. This unusual experiment sparked questions about how best to handle large animal carcasses and whether such extreme measures are ever appropriate. Known as the explosive whale experiment, the incident stands as a reminder that quick solutions can sometimes lead to unintended consequences. It has since become a notable story in ecological history, highlighting the risks of drastic human intervention. The key takeaway is this: when nature presents unexpected challenges, it's important to carefully consider our response to avoid making matters worse. The Oregon whale incident offers a valuable lesson in caution and planning. Operation Cat Drop. Far from a typical wildlife intervention, Operation Cat Drop in Borneo stands as a remarkable example of unintended ecological consequences and creative problem-solving. During efforts to control malaria, insecticides were sprayed extensively across the island, which unfortunately led to the accidental elimination of the local cat population. This unexpected loss had serious repercussions, as without their natural predators, the rat population exploded. With rats multiplying rapidly, the risk of disease, including plague, increased dramatically, posing a significant threat to both the environment and the local communities. To address this growing crisis, the British Royal Air Force was called in to execute a highly unusual plan, parachuting live cats back onto the island to restore the balance. This operation was not just an inventive solution, but also a rare example of how human intervention in one part of an ecosystem can create a chain reaction affecting many other species. The sudden removal of cats disrupted the natural control of rodents, demonstrating how interconnected and delicate ecosystems truly are. The parachuting of cats may sound extraordinary, but it was a practical and effective response to an urgent problem. The cats quickly resumed their role as natural predators, helping to reduce the rat population and limit the spread of disease. Operation Cat Drop serves as a powerful lesson in ecological management, highlighting the importance of considering all parts of an ecosystem before taking action. It also illustrates how sometimes solutions require unconventional thinking and a willingness to act quickly in the face of unforeseen consequences. Cane toads. Every attempt to control pests in Australia's sugar plantations took a drastic turn with the introduction of cane toads. Originally brought in to reduce the population of beetles damaging crops, these toads quickly multiplied beyond expectations. Rather than solving the problem, they became an invasive species, causing widespread damage to the local environment. Cane toads are highly toxic, and their presence has had severe consequences for native wildlife. Many predators that tried to eat the toads were poisoned, leading to declines in populations of animals such as snakes, lizards, and small mammals. The toads spread rapidly across large areas of northern Australia, disrupting ecosystems and threatening biodiversity. This situation shows how introducing a non-native species as a form of pest control can have unintended and far-reaching effects. The initial plan, intended to protect crops and improve agricultural productivity, instead sparked an ecological crisis that continues to challenge conservation efforts today. Efforts to manage the cane toad population have included research into biological controls and public awareness campaigns, but the toads remain a persistent problem. Wolf resurrection. Nothing illustrates the power of ecological restoration quite like the reintroduction of wolves to Yellowstone National Park. After being completely eliminated in the early 1900s, wolves were brought back in the mid-1990s with the primary goal of controlling an overpopulated elk herd that was damaging the park's vegetation. However, the effects of their return went far beyond just managing elk numbers. The presence of wolves changed elk behavior, causing them to avoid certain areas. This shift allowed vegetation to recover, particularly along riverbanks, where new growth stabilized soil and reduced erosion. As plants and trees flourished, beavers returned to the park, building dams that created habitats for other wildlife. Birds, fish, and a variety of species benefited from these changes, leading to a healthier and more balanced ecosystem overall. Scientists refer to this phenomenon as a trophic cascade, where the reintroduction of a top predator triggers a series of positive ecological effects throughout the food chain. Yellowstone's experience is one of the clearest examples of how restoring a single species can reshape an entire environment. The success of the Wolf Restoration Project shows that sometimes the best approach to healing nature is to allow it to regain its natural balance. In the end, the Yellowstone wolf comeback is a powerful reminder that ecosystems are interconnected, and restoring one key element can lead to remarkable, far-reaching improvements. Penguins and islands. Can relocating a species to an entirely different environment succeed? In the 1930s, Norway attempted to introduce penguins to the Lofoten Islands, far from their native Antarctic habitat. The goal was to establish a new colony, but the experiment quickly revealed the challenges of moving animals outside their natural range. Penguins are adapted to cold, icy conditions, while the Lofoten Islands offered a much warmer climate, different terrain, and unfamiliar food sources. These environmental differences made survival difficult for the penguins. Even with efforts to help them settle, the colony struggled and ultimately failed to establish itself. This case highlights the limits of ecological experiments that disregard the specific needs and adaptations of species. Moving animals into unsuitable habitats can have serious consequences and often leads to failure. The penguin introduction to the Lofoten Islands serves as a clear example of how nature's boundaries exist for important reasons. How often are species relocated without fully understanding the complexities involved? This story reminds us that conservation and ecological management require careful planning, respect for natural habitats, and a deep understanding of species biology. The failed attempt to introduce penguins outside their natural range shows the risks of disrupting ecological balance. It underscores the importance of working with nature rather than against it when undertaking such experiments. Shakespeare's Starling Storm. Whenever humans intervene in nature without fully understanding the consequences, unexpected problems can arise. In 1890, a group of Shakespeare enthusiasts introduced European starlings to New York's Central Park, aiming to bring every bird species mentioned in Shakespeare's plays to America. What began as a literary tribute quickly turned into a serious ecological issue. The starlings adapted exceptionally well to their new environment. With no natural predators and abundant food sources, their numbers grew rapidly. Soon, they spread throughout North America, transforming from a symbolic gesture into an invasive species that causes significant problems. These days, European starlings compete aggressively with native birds for nesting sites and food, often displacing them. They also damage crops and create nuisances in urban areas. What was intended as a tribute to literature inadvertently led to a widespread ecological disruption. It prompts us to reflect on how many other introductions, seemingly harmless at the time, might be quietly altering ecosystems today. Fire ant apocalypse. From a small accidental introduction in the 1930s, Brazilian fire ants have become one of the most destructive invasive species in North America. Known for their aggressive behavior and painful stings, these ants quickly spread across several states, creating widespread ecological and economic problems. The fire ants did not simply settle in quietly. Their rapid expansion disrupted native insect populations and negatively affected livestock health. In addition, they caused significant damage to electrical infrastructure by nesting inside power lines and transformers, leading to costly repairs and power outages. This phenomenon has been termed the fire ant apocalypse, due to the severe impact these ants have had on ecosystems and human activities. The invasion of Brazilian fire ants illustrates how the introduction of a single species into a new environment can trigger widespread ecological imbalance and economic damage. The fire ant apocalypse underscores the need for vigilance and proactive measures to protect ecosystems from invasive species. Elephant LSD experiment. Just one decision in 1962 led to a tragic and unforgettable scientific failure. Researchers injected an elephant named Tusco with an extremely high dose of LSD, aiming to test whether the drug could reduce aggressive behavior in elephants. The amount given was about 300 times the normal human dose, an extreme level that had dangerous consequences. Instead of calming the animal, the LSD caused severe physical distress, and Tusco died within hours of the injection. This shocking result not only stunned the scientific community, but also raised serious ethical questions about the experiment's justification and safety measures. The incident is now remembered as a stark example of the risks involved when experiments proceed without thorough understanding or caution. It underscores how dangerous it can be to conduct tests on living creatures without fully anticipating possible outcomes. Ultimately, the story of the elephant LSD experiment remains an influential warning about the consequences of reckless experimentation. It challenges researchers to think carefully about the impact of their work and the importance of safeguarding animal welfare.
Okay, now it's time for the open discussion.
No one could believe it when thousands of rats were released on a remote island. The results shocked everyone, even the scientists who planned it. The Golden Beach is nearly swallowed by a sea of twitching, matted fur. But what drove them to congregate like this? Was it nature's plan or man's mistake? Who controls this chaos now? The image alone raises more questions than answers. Drop your thoughts below, and don't forget to mention #OpenDiscussion. Mongoose mayhem. This one stands as a clear example of how well-meaning solutions can lead to unintended consequences. In the late 1800s, Hawaiian sugarcane farmers introduced mongooses to control rats that were damaging their crops. The idea seems straightforward: bring in a natural predator to eliminate the pests. However, the outcome was far from what anyone expected. Instead of focusing solely on rats, the mongooses began preying on native birds, their eggs, and other local wildlife that had no natural defenses against this fast and aggressive newcomer. As their numbers grew rapidly, the mongooses became a serious threat to Hawaii's native species, disrupting the ecological balance across the islands. The introduction of mongooses created a new problem while attempting to solve another, demonstrating the risks of bringing non-native species into an ecosystem. This invasion made pest control even more complicated and had long-lasting impacts on Hawaii's environment. Mouse utopia. Some scientific experiments reveal unexpected truths, and the mouse utopia study from the 1960s is a profound example. Researcher John Calhoun designed a controlled environment where mice had unlimited food, water, and shelter, aiming to observe how their population and behavior would evolve under ideal conditions. Initially, the environment appeared perfect for growth. However, as the population grew dense, the mice began exhibiting disturbing behaviors. Aggression increased, social bonds broke down, and acts of cannibalism emerged. What was intended to be a thriving community quickly deteriorated into disorder. Calhoun's study raised serious concerns about the effects of overcrowding and social stress. The results suggested that high population density can lead to social collapse, a pattern that might extend beyond mice to other species, including humans. This experiment goes beyond rodent behavior. It works as a cautionary example of the fragile nature of social structures when pushed beyond their limits. The mouse utopia experiment remains a significant and thought-provoking study. It highlights the dangers of overcrowding and underscores the importance of understanding social dynamics in both animals and people. Atomic gardening. What happens when scientists expose seeds to nuclear radiation in hopes of creating stronger, more resilient crops? During the Cold War, this question led to the unusual practice known as atomic gardening. The goal was to induce genetic mutations through radiation, aiming to develop plants that could better withstand environmental challenges and increase food production. The outcomes, however, were far from the intended breakthroughs. Instead of producing improved crops, the experiments yielded a wide range of unexpected and often undesirable mutations. Many plants developed deformities or abnormalities that made them unsuitable for consumption or growth. The results were random and unpredictable, demonstrating that radiation did not simply create beneficial changes. This experiment revealed important lessons about the limits of manipulating genetics through radiation, rather than a straightforward path to agricultural innovation. Atomic gardening highlighted the risks and uncertainties involved in such approaches. It showed that genetic mutations caused by radiation can be more harmful than helpful. The atomic gardening experiments serve as a reminder that scientific progress is rarely simple or guaranteed. Not all attempts to accelerate development lead to success. Some result in unexpected complications. Killer bees gone rogue. Although the original intention was to improve honey production, the experiment involving the crossbreeding of African and European honeybees in Brazil during the 1950s led to unintended and dangerous consequences. The resulting hybrid bees, later known as killer bees, proved to be far more aggressive than anticipated. Unlike their European counterparts, these Africanized bees are highly defensive and attack in large swarms. After escaping containment, they rapidly spread throughout the Americas, causing concern for both human safety and local ecosystems. Their expansion disrupted native species and presented a serious threat to people and animals. This situation serves as a clear example of how human interference with natural systems can have unpredictable and often harmful effects. What began as an effort to increase honey yields transformed into a widespread ecological challenge affecting multiple countries. It stands as a cautionary tale about the need for careful consideration and respect when altering the natural world. Mosquito gene hack. Can genetic engineering provide a solution to controlling deadly diseases like malaria and dengue? In recent years, scientists have developed genetically modified mosquitoes designed to reduce populations that carry these illnesses. By altering the mosquitoes' genes, the goal was to limit their numbers and decrease disease transmission, a potentially revolutionary approach. However, the outcomes have proven more complicated than anticipated. Some genetically engineered mosquitoes have developed resistance, and concerns have arisen about the possible emergence of super mosquitoes that could be harder to control and potentially more harmful. These unexpected developments have prompted scientists to reconsider the safety and long-term effectiveness of this technology. The experiment highlights the fragile balance involved when intervening in ecosystems through genetic modification. It raises important questions about the unintended consequences of manipulating nature's genetic code without fully understanding the potential risks. This case forces us to consider whether genetic engineering is the best path forward for disease control, or if it might introduce new and unforeseen problems. The complexity of the situation demonstrates how cutting-edge scientific advancements often come with significant uncertainties. Florida's python. So, the issue began with pet owners releasing or losing their Burmese pythons into Florida's Everglades, unknowingly setting off one of the most serious ecological problems in the region. These large snakes found the warm, swampy environment ideal for survival and reproduction, allowing their population to grow rapidly. The pythons have become apex predators in the Everglades, feeding on a wide variety of native mammals, birds, and reptiles. Their presence has caused severe declines in many native species, disrupting the delicate balance of this unique ecosystem. What makes the situation more challenging is how difficult it is to detect and control these elusive snakes. Authorities have attempted various strategies to manage the python population, including organized hunts and trapping efforts. Despite these measures, the snakes continue to thrive and spread, illustrating how hard it is to reverse the effects of an introduced invasive species once it becomes established. Florida's python problem is a clear example of how quickly ecosystems can be altered when invasive species are introduced. It reminds us that ecosystems are fragile and that careless actions can lead to lasting damage. Arctic Fox Island disaster. Noting the intentions behind introducing Arctic foxes to the Aleutian Islands in the 19th century, the outcome was far from what the Russian fur traders expected. Their goal was to boost fur production, but they did not foresee the severe damage these foxes would cause to the island's delicate ecosystems. Without natural predators to keep their numbers in check, the foxes rapidly preyed on native seabird populations. Entire colonies, including eggs and chicks, were decimated, leading to long-lasting ecological damage. The disappearance of these birds disrupted the balance that had existed on the islands for centuries. The introduction of the Arctic fox stands as a clear example of how human actions, despite good intentions, can lead to unforeseen and significant negative impacts. The frog pregnancy test disaster. What started as a hopeful medical innovation quickly spiraled into a devastating global catastrophe. In the mid-1900s, African clawed frogs were brought into laboratories as part of a groundbreaking pregnancy test. Inject a woman's urine, and if the frog laid eggs, pregnancy was confirmed. At the time, it seemed like a remarkable scientific triumph, but the triumph concealed a dark consequence. Some of these frogs escaped into the wild, unknowingly carrying a lethal fungal enemy, the chytrid fungus. This invisible killer spread like wildfire, wiping out amphibian populations across continents. Entire species vanished, ecosystems were thrown into chaos, and a silent extinction crisis unfolded. This chilling chapter reveals how even humanity's brightest ideas can unleash unforeseen destruction. The frog pregnancy test disaster stands as a haunting reminder of how fragile life is and how deeply our actions ripple through the web of nature. It forces us to confront a harsh truth. How often do we fail to see the dangers lurking behind progress? This tale is not just about frogs. It is a stark warning about the unpredictable fallout of meddling with nature's balance. The accidental island of plastic. When scientists began studying ocean currents in the North Pacific, they discovered something unexpected and alarming: a massive accumulation of plastic debris floating in the water. This formation, now known as the Great Pacific Garbage Patch, is essentially a huge island of plastic waste drifting in the middle of the ocean. Unlike natural islands, it is entirely man-made, created by years of human pollution. The patch consists of millions of tons of plastic, ranging from tiny microplastics to large discarded items, all trapped by the circular motion of ocean currents. This accumulation highlights the severe impact of human waste on marine environments. The plastic harms wildlife, disrupts ecosystems, and even makes its way into the food chain, posing risks to animals and humans alike. What started as an oceanographic study soon became a powerful symbol of environmental neglect. The Great Pacific Garbage Patch forces us to confront the reality that our plastic pollution does not simply disappear. It accumulates in places where it causes lasting damage. Miracle fish gone wrong. Does introducing a single species with good intentions always lead to positive outcomes? The story of the Nile perch in Lake Victoria provides a striking answer. In the 1960s, the Nile perch was introduced to the lake to boost fishing and support local economies. At first glance, this appeared to be a beneficial move. However, the Nile perch quickly became a destructive force. As a powerful predator, it decimated hundreds of native fish species, many of which were unique to Lake Victoria. The dramatic loss of biodiversity caused the collapse of the lake's fragile ecosystem, disrupting food chains and harming communities that depended on fishing for their livelihoods. The consequences have persisted for decades, affecting both the environment and local populations. In conclusion, the Nile perch invasion stands as a cautionary tale of ecological disruption. It reminds us that ecosystems are complex, and well-meaning actions can sometimes lead to unintended and serious consequences. Thanks for watching. If you enjoyed these wild ecological experiments, hit like, subscribe, and share. Got a favorite story or suggestion? Drop it in the comments below. See you next time.